let me know when
It's like, okay, it's recording. All right, welcome to another awesome CSTA San Diego Happy Hour series. So today we have Douglas Kiang from Hawaii. Thank you for joining us, Douglas. Why don't you go ahead and introduce yourself?
Thank you. Yeah, so I'm Douglas Kiang, and I am a computer science teacher, and I'm also on the board of a new CSTA chapter, CSTA in Hawaii. It's our first chapter. We're in our second year now, and you know, we were so inspired by the work that you're doing at CSTA San Diego, and we looked around the country for exemplars of clubs that were very active and were doing lots of interesting kinds of speaking series and other kinds of things. So, you know, I want to sort of tell you that we sort of shamelessly borrowed and tried to aspire to a lot of what you're doing so well in this club. So it was a huge honor for me to be asked to present, you know, by my friend Art and by Min as well. So I want to say thank you to them. So it's super exciting for me to be here. So.
Well, I think we're really excited to have you here, Douglas. Everybody, I don't know if you've ever met Douglas. He's famous, a rock star in CS education, and I'm really excited for him to present for us. And I also got the opportunity to hang out with Douglas a little bit in Hawaii, in Oahu, and that was really super cool. So, you know, Douglas, take it away.
Thank you. Thanks so much. So let me go ahead and share my screen here. Let's see. So I actually couldn't decide which of these two things to do. So I kind of did a mashup because these are both things that I'm really interested and really involved in. So what we're going to talk about today is basically this idea of belonging in computer science and how that affects girls and minorities and how we can increase that sense of belonging. I also really love to provide context around computer science. And I think one of the most interesting fields and areas right now is AI and machine learning. And so I have like a whole other presentation that I do that talks about the difference between AI and machine learning. And it kind of models how I approach that with kids and how I present it. So if we have time towards the end, I'm going to kind of just throw that in there. It's going to seem like it's sort of bolted on. And it is because it's sort of bolted on, but it's, I think, a good example of this idea of providing context over tools. And so the idea behind these strategies is I've done a lot of work in terms of thinking about and looking at the research in terms of what helps get more girls involved in computer science and then supports them. A lot of the issues that girls face, I think, are shared by a lot of minorities, underrepresented populations of kids. And so even though a lot of my research and my work deals specifically with supporting girls, a lot of it I think can be extrapolated to minority groups as well. Basically, it boils down to these 6 things are things that I've done in my classroom. And we're going to go over each of these, and I'll share these slides out later. But just to give you a bit of context, so I teach at Punahou School. We're the largest independent school on a single campus in the country. So we have 3,750 students in grades K through 12. And when I started teaching here, we had 2 computer science classes, an intro and an AP course, and maybe we would have 1 or 2 girls. Actually, some years we had 0 girls. And some years we'd have 1 girl join and then she'd immediately drop. And so I've tried to put a lot of these practices, and I'm going to talk about, into practice. And we are now up to 50% boys and girls. And I'm going to tell you a little bit about sort of what I've seen from the research. This I thought was very striking to me. One study showed that it's not so important, because I always felt I was at a bit of a disadvantage, because here I am saying girls can do computer science, but I'm not a girl. But it turns out whether that role model projects current stereotypes of the field actually seems to have a greater effect than actually being male or female. So I think even as male role models, we have a lot to play in the idea of dispelling negative stereotypes and helping to show positive examples of women who are successful in computer science. And that really goes to the sense of belonging. And in the research, belonging pretty much is defined sort of in these 2 categories. First of all, do I fit in? And then do I have what it takes? And so if you think about the message that you project to your students, think about those 2 components. Unfortunately, today's culture, there are a lot of negative stereotypes, even from shows that we love, like Big Bang Theory, Mr. Robot. The stereotype of the computer expert is usually a loner. someone who's kind of borderline autistic, antisocial, just kind of doesn't quite fit in, kind of an oddball. And that's kind of that's kind of exclusionary. And in some ways, that's become celebrated by the kids who are part of that rarefied group who have traditionally been drawn to computer science. One of the best ways that I found to promote my course is to have kids do t-shirts, because kids can wear t-shirts to school and the t-shirts say computer science. So I used to have the kids design them, and they would promote things like this. They'd come up, if I ask kids to design a computer science t-shirt, you've probably seen a lot of these. And the message that these shirts give, I mean, they're funny, but the message is very much that this is an exclusive club that you probably don't know enough to belong to. And there's something special when we talk about forming a community. Community, we know, is really important to helping support kids when they struggle. But it's important that that idea of community not be too closely tied to the exclusionary aspect of that community. In other words, we are so exclusive that you've got to be a brainerd or a nerd to be able to fit in. So the challenge for us, I think, is to widen this idea of community and say anyone can belong. You belong here. But to be part of the community, you have to contribute, you have to do these other things. And so we're going to talk about some different ways to do that. But that's that idea of, do I fit in? And I was inspired by Mike Wexler does this great activity. if you'll bear with me, try crossing your hands just like this, trying to fold your hands together in a way that feels comfortable. And when you do that, kind of notice which thumb is over which thumb. For some of you, your right thumb will be over your left thumb. And for some other people, your left thumb will be over your right thumb. And I would ask for a show of hands, which is which, but you all have your hands clasped, so you can't really do that. But what I want you to do is notice what's over which one. Now I want you to unclasp your hands and fold them the other way so your other thumb is over the other one. And so now that you've folded your hands, quote, the wrong way for you, again, probably about half of you are one way and half are the other. And just feel what that feels like. It doesn't feel so good, does it? I mean, your hands are still clasped, but it still feels a little awkward. That's the feeling that's what it feels like to be a minority in a group where everybody is there and you know you're smart enough, you can do it. But everything about it has some friction to it. It doesn't quite feel right. And that's what I try to remind, kids who are in the majority, that it feels like you're struggling to fit in always a little bit. And that's a simple thing that you can do to remind yourself, what does it feel like to feel awkward doing something? Things just don't quite feel right. And so the challenge is, how do we foster a greater sense of belonging in the class? So here are some strategies. The first one is providing positive role models. So I will bring people in to be guest speakers. So I've reached out to people. It's actually never been easier actually now. I mean, there are people who I think would be impossible to bring to Hawaii to speak to my group, or people who we would have to pay to bring them out. Now they're all sitting at home. A lot of them, if I just reach out, I can ask. We're having Emily Chang, who wrote Brotopia, speak to my class, and it was a New York Times bestseller about life in Silicon Valley. And I just reached out to her on Twitter and said, "Hey, would you come speak to my class?" And she's going to do it. So I mean, it's amazing. So bringing in role models and guest speakers, super important. I try to bring in women to kind of counterbalance. I'm the male figure that's there every day, but I've had kids tell me that Ashley kind of made the biggest impression on them, because she told them that computer science is not all about sitting at your cubicle. A lot of it is having meetings and walking around and talking to people and collaborating, and that's a big part of it. I had told them that too, but when Ashley said it, and she works in the Xbox Live, I mean that resonates with them. So I try to get the message across in as many different ways as I can. So Google's madewithcode.com. A lot of you probably already know about this, but I love pointing it to people again. There are these great little mini videos that just talk about, they're just stories about role models and people in the community, people who are using code to solve real problems, providing that context and providing some positive role models that people these are some people who are successful in the field. That's really important. Now, connected to that is basically seeing others who look like you being successful. So if you're a girl and you see women who are in the field, you can start to picture yourself being a successful woman in computer science. But seeing others maybe who look like you more recently is big too. So I have course assistants. So every year I have a couple of kids come back from a previous year and they work with the kids. And this is really helpful because some kids, for whatever reason, like they won't come and talk to me if they're having help or if they need help or if they're thinking about dropping the course. But I always have a male and a female course assistant, and I kind of stagger them so that every year, the kid who's coming back for her second year will be mentoring a kid who's in his first year. So typically kids will do 2 years and one will mentor the other. So that's really helpful. They will do videos, walk through videos for me, meet with kids one-on-one, talk to kids who are thinking of dropping the course. I had my course assistant this year, she had an interaction with a girl in the class who was thinking of dropping, and she said, you know, I know it's really tough now. It was tough for me last year, but I stuck with it. And look at what I'm doing now. I would have never thought I would be here, but if I can do it, you can totally do it. And that was a really powerful message. It was a message that I couldn't have given in the same way. And that girl stayed in, and she's getting an A now. And so, I mean, it's pretty amazing, the difference that it makes when you have other kids who are role models in the class. We do promotional videos. So again, we're trying to counteract that popular note of, you know, computer science is just about sitting in your room coding on your own. Coding is collaborative, coding is problem solving. And so here's a YouTube video that we show that kind of shows a little bit about what it's like in my class. Strategy number 3 is encouragement from other adults. And I hadn't really thought about this, to be honest, until I heard from some students that some of the counselors had no idea what we were doing in our class. And they were actually steering kids away from computer science because they're saying, well, this is a 6th course. This is really going to be hard for you. So why don't you try AP Environmental Science instead? Or, gosh, you know, you are so great at talking and collaborating with other people. Why don't you try this course instead of computer science? So there's a lot of stereotypes and ideas that are kind of built into adults who maybe either didn't take computer science or took it a long time ago when computer science was very different. And they have a big effect on kids. The research shows they also have a positive effect too. So if an adult that you know tells you, hey, you know, you could be really successful in this, that has an outsized effect on students' willingness to engage in computer science. And so educating the adults in your community is just as important as educating the kids. I actually print up flyers and I pass the flyers out to the counselors and I say, here, if kids are curious about computer science, don't make it up. Have them look at the flyer and then have them contact me if they've got questions. When I do parents' nights, I show parents things like this. This is popularity of majors at Harvard. Econ is the most popular major. It always has been. But look at computer science. It's the blue bar. Look what's happened in the last few years. It has quickly overshot everything else to be the number 2 major at Harvard. And I think at probably a lot of other schools as well. This was a study from the New York Times. This is fascinating. I think the number of graduates with STEM majors versus the number of job openings in pink. The only one where there are more job openings than there are qualified candidates is computer science. But like, look at engineering. Your kid says, yeah, I'm going to go major in engineering. There's not as many jobs out there, you know, related to the number of people with engineering degrees. So this I found to be a little less compelling for my kids. They're not thinking ahead that way about jobs, but when parents see that, whoa, boy, then they're like, gee, I'm going to encourage my kid to at least give this a try. I love this idea. The National Center for Women in Information Technology has got lots of great resources about inclusion and diversity and how that helps to improve the workforce. Super important, so it's worth taking a look at that. Strategy number 4 is providing some context over tools. This is actually really important because what I found, at least anecdotally, is the boys tend to be much more tools focused. Like they want to know they're the first ones to say, well, what language are we studying? And the focus even for the male teachers is, oh, you're going to teach computer science. Well, what language? What tool? They're very tools focused. We used to advertise one of our courses this way. So this is Introduction to JavaScript. And this is an intro course description. And the more I looked at this, the more that I realized, who is this written for? Is this written for the type of student who you're trying to attract to an intro course? And isn't a description like this, kind of like if you had Introduction to Japanese and that was the description, right? Again, like who is that written for and how is that going to really help you? So we had that same course, but we rewrote the course description to basically do this. So we're working with the community organization. Here's what you're going to be doing. Here are some of the people that we've worked with, and here are the problems you're going to solve. Now, at its core, it's still the same course. They're still studying JavaScript, but the tools are not as important. It's much more important, what are we doing with it? And what I found is a lot of girls, when they look at that, they'll say, oh, I want to do that. Or, gosh, I know somebody in Malama Honua. I want to do that. And then if they find out, well, we need to learn JavaScript and Ajax, and they'll be like, oh, no problem, I can do that. So this, I mean, I think you need to do more to the course, but this is a good starting point, at least, to really start, you know, how you talk about your courses, how you advertise them makes a big difference. We bring in guest speakers. So we've had Malin, Professor Malin from CS50 come in and speak, and we make an event out of it. We serve cookies and we get kids out there and get kids talking. And we really make this idea of thinking about taking computer science more of a social experience, like a cocktail hour, rather than just browsing through a catalog. Entrepreneurship is really big now, and I think it's a natural match for teaching computer science skills. So if we're building an app, we're going to build an app or build a toolkit that will solve a problem. What might that look like? And so these are a couple of my students, and they actually designed these bracelets that you could program using a microprocessor. And so they did actually a craft fair, they did a little presentation at Barnes & Noble, and they got kids involved, and their idea was to create a kit that they could actually sell for not much more than the cost of the parts and their time developing it. And that added a context for learning the computer science skills. That was very powerful. So strategy number 5 is kind of increasing the sense of community and collaboration so that you're not alone. And you're really helping students connect with peers who can provide perspective on their abilities. So this study kind of shows that when girls are interested in technology, a lot more often they're motivated by social interaction or by helping others. And so this idea of help me understand your thinking here becomes very powerful. We tend to do social code review. So when I get kids at the end of a unit or an end of a problem, I'll actually have them talk about what they're doing, or even in the process of working on something. So this is an example of what we call a work in progress report. And these are really simple. When we're working on something, well, every so often I'll stop and everybody will get up and they'll kind of stand behind someone's computer, and each person will just take about 30 seconds to show where they are in the process of the project and maybe one aha moment or one thing that they've filled out or that they've figured out or something that they're proud of. And then everybody gets up and moves to the next person, and then they take a look at their screen, and everybody gets used to moving around the classroom. And you can do this pretty effectively in a small class. If you have a larger class, and I split it into 2. But I get the kids in the habit of talking about what they're doing before they're done with it, because that gets you away from that perfectionist attitude that I can't show this until it's perfect. And it gets kids used to moving around and talking about what they're doing. And I always have 2 rules. The first rule is you don't start until everybody can see your screen and is paying attention. And second, you don't apologize. You never start out with saying, I'm really sorry, or this isn't quite what I wanted, but, and I make this part of the classroom routine. The other thing we do once a year is we do Puzzle Day. And Puzzle Day, you don't need any computer science experience. You just kind of need to love solving puzzles. And the kids get together and we serve pizza. And you can see that we have just paper and pencil puzzles that the kids kind of try to solve. And I have them invite a friend. So it's all the computer science students are invited, but then any friends who are interested as well. And so a lot of specifically a lot of the girls that I've had take the course in successive years started at a Puzzle Day, because they knew kids who were taking the class who invited them. And it was less of an investment than saying, hey, take computer science with me. But when they said, oh, computer science is actually the art of solving interesting puzzles, that made it much more interesting to them. These are freshmen. So there's a great program called Girls Go Cyber Start. And it's really well done. It's web-based. The girls solve mysteries. It's cybersecurity, but I think it's fun to kind of start forming that social group around getting together and solving puzzles together, because probably 3 out of these 4 girls, I think, ended up taking computer science in the following year. And they just came for the puzzles and they stayed for the computer science. We run a Slack channel, and the Slack channel is great because it makes you feel less like you're alone. Like I usually say, you have to do this course together. You can't do it alone. You have to work with other people. And even after I've gone to bed, kids are posting questions and they're getting answers from either the course assistants or from other students who have finished the problem set and are willing to give hints. And so this kind of works really nicely. And I've even had kids who are alums come back and they're still part of the Slack channel. So we now have a group of about 400 computer science students who've taken CS in the last maybe 5 years. And that provides a lot of support to kids. And then finally, the growth mindset is super important. You know, how kids feel about computer science has a lot to do with whether they feel that you are a computer science person or you're not a computer science person. This idea that, you know, you either get computer science or you don't, I think is really destructive. It really, you got to get across the idea that there is no such thing as a math person or a computer science person. The growth mindset is, if I work at this, I can get better at this. And we acknowledge right up front, we say, this is hard stuff and you will get stuck. So let's work on strategies to get yourself unstuck, because getting stuck is part of, and I would almost go so far as to say it's part of the fun of computer science, is being stuck. And then that elation that you feel when you figure something out. And I've had kids say, I felt like running around my room and screaming, except it was late at night. I didn't want to wake anybody up. But that's that feeling that that I think I want kids to understand, that you can get that. But computer science involves lots of failure, and it is an iterative process. It's not like a math class where it goes step by step at the lower levels and you kind of get scaffolded. And that's something that it's taken me a bit of time to get my department to understand, is that it is much more design oriented than it is math oriented in that way, even though it does involve math skills. I love these by Julia Evans. So she put up these cute little things. I actually had them blown up and they're posters, but this is the growth mindset. You know, how I got better at debugging. Remember, it's happening for a logical reason. This is the narrative that kids can tell themselves to help them when they get stuck. Definitely worth, you can look this up online and find these. I love this. The more programming I do, the more things I run into where I don't know, Google doesn't know, my colleagues don't know, but we got to do it anyway. And that's where I think that's why they pay me, because I'm a human who can figure this stuff out and investigate. I have what I call the 45-minute rule with kids. If you're stuck for more than 45 minutes on a problem, please come talk to me. Don't keep hitting your head against the same wall for 3 hours. Change the variables a little bit, or even go to bed and wake up in the morning and then look at it with fresh eyes. But the 45-minute rule is something we try to do. We teach them about rubber duck debugging, which is the idea that if you articulate the problem and talk to the problem, often you can figure things out. So I'll tell them, even when you're alone, you're never totally alone because you have your duck. And we give our kids a duck as part of the computer science course. So again, I kind of zip through all these really quickly. When we do the open discussion, I'm sure a lot of you will have other things that you can add to it. But just to summarize, again, providing positive role models makes a big difference. Sharing student success is super important. Look at the adults in your community, look at the gatekeepers, and kind of do some outreach that way. Remember to promote context over the tools. Find ways to build community and collaboration into your classroom, and always foster that growth mindset with kids. It's hard, but we can get better at this together. Okay, so, all right, so I zipped through that real quick. Love to hear, let's see, I guess what people, yeah, thanks, Beth. Yeah, definitely. Yeah, you work really hard and it shows in how well you, yep. The language that we use is super important. Yep, absolutely. Yep.
Hey, Douglas, is it cool that we have people before you jump into the AI, or do you want to jump into the
Sure.
AI, or would you like for us to make some comments about what you just presented? What would you like to do?
Well, how are we doing on time?
Min?
Usually we have presenters present at from 5 to 5:30, and we just have like an open space community happy hour. But I'll leave the floor up to folks and see what y'all feel like. I'm flexible.
I'm happy to hang out for the rest of the hour. I got about 10 minutes more on some other stuff that I think you might find interesting, but I'm also happy to stop if people feel like they want to stop and discuss. I'm fine with that too, or I can keep going and then we can talk about everything if you like.
We have somebody saying here about hearing AI, so just keep going.
All right, let's go.
Yeah, keep going.
So, and this is actually adapted from a presentation that I give kids because, again, like I find it really interesting to try to bring in things that kids have noticed and to get them interested in talking more about computer science. And so one entry point that I think is really topical and relevant is this thing that kids run into all the time on the web called a CAPTCHA. And we talk about why CAPTCHAs were invented and what they do. And, you know, like at some point, and then they started doing really interesting things like I'm not a robot. The way that that works is before you click the check mark, it's already watching what you're doing. And so if the cursor starts at the side of the screen and goes in a perfectly linear path to the checkbox and clicks it, then yeah, you are probably a robot. So it's looking for, you know, so you can measure like velocity and change over time and see, is it perfectly linear or is it somewhat random? And so that's one of the things that you can use. But, you know, it's an arms race. So computer science engineers, I'm sure some of them have worked to come up with ways to fool the I'm not a robot by building in some randomness into how the cursor tracks. And then they have other ways to kind of get around it. And so it's really gone back and forth quite a bit. Now they actually have with T. And so that's kind of the latest version of the CAPTCHA. And so I guess the theory is only human beings can identify T. Now they have you selecting all images with street numbers or select all squares with traffic lights, which is actually a really tough problem because it's like, okay, how much of those squares really have a traffic light? Like, is the pole part of the traffic light? I mean, it's kind of a philosophical question, right? I mean, technically it is. I mean, and the bottom line is it doesn't really matter because if enough people have identified that 6 or 8 squares are the traffic light, then I think it kind of goes with that answer. Because by this point, we've given up on trying to differentiate humans from computers using this test. What we're really doing is we're building a training set for computers so that computers can get better at recognizing street signs and traffic lights in different lighting conditions and from different angles. And I usually stop at this point to ask kids about why are we training computers to be able to read street numbers and traffic lights? And of course, it's the self-driving cars and the autonomous vehicles, right? So, so it's interesting that when kids are doing this, to get them thinking about why are we doing this? There's a really great podcast episode. I think it was, I will find it, but it's called I'm Not a Robot. And it's about the history of the CAPTCHA. It's really, really good. And I actually assign this to students. I'll find it and post that. But it's a podcast called I'm Not a Robot. And I want to say it was Planet Money, maybe? I don't know. I'll find it. But, you know, if you think about it, like it's really hard to program computers using algorithms. So things that human beings do very easily, like telling the difference between a Chihuahua and a blueberry muffin. Like how would you teach a computer how to tell the difference if you had to do it using algorithms, right? Like this is a really, really hard task with potentially tragic consequences if you get it wrong. So what we've started to do is figure out that if you show a computer enough pictures of blueberry muffins and dogs, that the computer will start to get a sense for which is which. There is a great online activity called Quick Draw in Google. And I usually at this point will bring out my iPad and I'll have kids actually draw with this. And what's really neat is you'll get a prompt like draw a penguin in under 20 seconds. And as you start drawing, the computer will actually start guessing what it thinks you're drawing until it figures it out. And it's surprisingly accurate. And what's really neat is after you take this test, you can kind of see, or you play a game, you can see how all these other people have drawn noses because it's asked all these people to draw it. And it has this training set. So this is over 100,000 phone drawings. So it says draw a cell phone. This is how people draw the phone. And again, if you wanted to get a computer to recognize a drawing of a phone, rather than writing an algorithm to do it, more and more what we're doing now is we're cultivating data sets and we're writing the model that the computer will use to analyze the training set. And that's, I think, one of the big ways that computer science is changing. We start kids by thinking about writing algorithms, but more and more the computational tasks are so sophisticated and so complex that we've moved beyond human programmed algorithms, aside from programming the model, and we're moving to have computers actually start programmed in themselves. So I often then transition to talking about this idea of a generational adversarial network, which is to say, if you've got a discriminator, if you've got a training set that can, like Google's Quick Draw, look at all these pictures and identify, okay, this is what this is. You know, you've probably seen this if you have photos, like on the Mac, photos, and I think probably Google Photos as well. It identifies things in photos that it's never seen before because it's been trained to recognize trees and mountains and dogs and your family members. And so that's essentially a discriminator. And so you can get a random noise generator to generate a fake image and try to fool the discriminator. And if the discriminator is not fooled and says, nope, that's fake, it sends it back. And then the generator comes up with another iteration on it. And the computers, because they're computers, they can play this game, you know, hundreds of thousands of times in a very short amount of time, to the point where the computer actually gets really, really good at generating fake images. So this person does not exist.com. If you go to that website, every time you reload it, this person is not a real person. It's not a real photo. In fact, none of these people are real people. And it's pretty amazing to keep kind of reloading this because it's, I mean, I swear I recognize some of these people sometimes and they never existed. They are generated on the fly. This article does not exist.com. This is actually pulling real headlines from real newspapers, and then they're having an algorithm essentially write a fake article. And the training set is all of the human written articles that get posted to the web all the time. And it's actually pretty amazing when you look at this. Some of the articles are clearly nonsense, but others, you'd be hard pressed to tell the difference. And it's getting better all the time. And so the ramifications for this are really kind of scary. If you think about what happened in our last election, you had a lot of fake news influencing the election. And back then on social media posts, you usually could tell the difference between a fake person's profile, because usually they would grab a photo from some other place on the net and you can run it into a Google reverse image search and kind of search it up and say, oh no, this appeared in an Instagram post 2 years ago. This is not the real person. But now you can go to this person does not exist, generate a picture of someone who has never existed in real life and has no fingerprint on the web, attach it to a social media profile, and then generate in a fraction of a second dozens or even hundreds of articles that maybe are critical of a certain political candidate or a certain party leaning, and just flood the social networks with this. So, I mean, it really is interesting about, you know, what is the next election going to look like? This is where computer science, again, I mean, it's a tool, right? It's neither good nor bad, it's a tool. And so, but having an understanding of what is possible, an understanding of how to help detect as well as generate a lot of this stuff, I think is going to be even more important. This movie came out recently, Alita Battle Angel. So if you can get computers to generate people that never existed as stills, you can also get them to generate video. And so this actually was a really neat one. I show a trailer from Alita Battle Angel where there's actually a human and a computer generated person acting side by side, and they both look like real people, except for eyes are abnormally large. So it makes you wonder, you know, what happens in the future with casting, right? Or especially in this pandemic where a lot of movies and a lot of shows are not going to be filming. Like this fall season is going to be pretty sparse because they're all supposed to be filming in person. They can't do it. But it's even more important that you get, you know, things like, so like the dog in Call of the Wild, the dog never existed. This is all computer generated. So again, you know, the ability of AI and machine learning to kind of figure out how to generate this stuff on the fly, I think is just going to be more and more a part of current events. And so this is sort of the opener that I give to kids. We did a computer science evening a number of weeks ago, right around the time we were doing new course signups, just to say, what is computer science? We had former students come and talk about their experience. We had both of our course assistants were there. We showed the clip from Alita Battle Angel when I talked about AI and machine learning. And then we did a quick activity, which I can run through real quick with you. So the idea with the beginning, like before I start this presentation, what I do is I do an activity with kids where I have them play tic-tac-toe. But then I say, okay, write down the rules for how to win at tic-tac-toe. And they write down a rule set, like always go in the center. Or if the center is taken, always go in a diagonal. Or if the center and the diagonal are taken, then look for 2 in a row. And I have them start to pseudocode out what would that algorithm look like. And then I have them switch papers and you have to play a different person, but you can only use the pseudocode that this other team wrote. So if it's not in the pseudocode, you can't play it that way. And then you kind of talk about how effective was that and what was challenging about writing that pseudocode out. So that's an exercise, that's what I call an exercise in artificial intelligence, because you're trying to write an algorithm that'll teach a computer to play like a human being. Machine learning is taking a training set of data and learning from that. So the bookend to the tic-tac-toe, after you've talked about AI and machine learning, is we have them play sticks. And the idea with sticks, also called poison, is you start out with a pile of sticks and you have to take 1, 2, or 3. You have to take at least one, and you take a maximum of 3 sticks, and you take turns. And the person who's stuck with the last stick loses. And we have them play it a bunch of times, and it's a fun game. But then we have them analyze it and start to figure out, well, you know, pretty quickly you realize that if you have 4 sticks left, and it's the other person's turn, you're probably going to lose. Because if they know how to play, they're going to take 3 sticks, their max, and it leaves you with 1, and you know, that's it. But if they don't know what they're doing and they just take 2, then you win, because then you can take 1 and then you stick them with the last one. So we have them keep a chart. And if you were going to pseudocode this, it starts to look like a really ugly if then else statement, right? If this, then that, or a switch case statement. So, you know, there's a better way to do this. So we think about it in terms of buckets and balls. And I adapted this from the Nifty. There's a great Nifty project on nifty.stanford.edu about exactly this. But the idea is, if you imagine you had a series of buckets and painted on each bucket is a number that represents the number of sticks that's left when it's your turn, you put 3 ping pong balls in the bucket with a 1, a 2, and a 3. Each of those ping pong balls represents how many you would take at that point when it's your turn. And then if, say, there are 7 left, you take a copy of one of those out at random. So randomly, I got a 1 out of 3 chance I pull a 3. And I put that ball next to the 7 bucket. And then we keep playing. Now there's 4 left, but it's the other person's turn, so they're going to do something. And then we're going to figure out. Actually, I'll probably lose at this point. But we'll figure out what happens. And let's say I won. Well, if I won, then the 3 goes back in the bucket. But remember, it's a copy. So now the chance that I'm going to draw a 3 is now 50% and 25% for the other 2. And the nice thing about it is after a while, you'll start to figure out which are the winning numbers, because more often than not, you'll end up with more of those balls. And because it's a computer, you can have the computer play lots and lots and lots of games. And you'll end up looking something like this, where experimentally, you're always going to have at least 1 of each move that's possible, but you'll have many more of the moves that actually win. And you can model this in like Java. Like this would be like an array of array lists. And you can actually model this and experimentally run it, and they can create a version of this where they can play against it and they can beat it pretty regularly. And then you run this training thing, and in about 2 seconds or less, now they can't beat it anymore, because the training set is so good, because it's played an instance of itself so many times. And so this is a very accessible activity that you can use to get across this idea of machine learning, which is you're letting the machine figure itself out experimentally rather than writing the algorithm. So, wow, that was a lot. So those are just, hopefully this has been helpful, it's given you some ideas, you know, however you're working with your students or other kinds of things. And I would love to chat more about any of this stuff, about either engaging and supporting girls and minorities, or ideas about, you know, getting some difficult topics across in a more approachable way. But again, thank you so much for listening and for being here and for inviting me, Art and Mint, to speak. It's, you know, again, it's a huge honor for me to be here. So thanks so much to you.
Actually, Douglas, thank you. As always, you're amazing. You know, you just come up with some great ideas, and the way you explain it is, man, I've known you for years, and you know, and I think I'm not going to speak for everybody here, but from my point of view, that was amazing. Thank you so much. That was really
Thanks
cool.
a lot.
So you can lend us these slide decks?
Yeah, absolutely.
Absolutely. I really can. I mean, you made me think about a lot of things already, and I'm gonna stop talking here, and I'm gonna say, Min, I guess so we could do the raise hand thing if people want to share and ask questions of Douglas. So does anybody want to make any comment or have a question for Douglas on any topic? You guys know how to use the raise hand feature on this program. Go ahead and raise your hand. I think Daniel Pearson has a question.
Sorry if I have background noise bleeding through. My daughter's zooming right behind me too. But I was curious, could you go over your buckets and balls thing again?
Sure. The whole thing, or do you have specific questions about it?
I guess the whole thing. I don't really have a specific question, sorry.
Yeah, sure. Let me do something first, because I do want to give credit where credit is due. I will find, so what really inspired me was an assignment in Nifty. And I'm going to pop it into chat. And if you haven't visited this before, this is a really great site. I like to send students who are looking for independent projects and need inspiration. I like to send them here. It's really well scaffolded. And there are lots of really great assignments in lots of different kinds of languages. But this is where I kind of basically first learned about this idea that, because the challenge to me was always like Google has a great machine learning course, but it's not really accessible to most kids. But most kids can get this idea of poison really quickly, and you can play it with anything. So like toothpicks, for example, and getting kids to kind of think about how do you win at this game. They have to start flowcharting it in their head and keeping it straight. And it's actually a pretty difficult game to come up with a algorithmic solution to it. And there are some variations that you can do where each move is dependent on the one before it, which actually makes it but just much more difficult computationally to try to get kids to code that. And so what I essentially did is, if you're playing with a fixed number of, like, let's say you play up to 21, I would create an array of 21 elements where each array element is itself an array list. And if the legal moves are 1, 2, or 3, I'd pretty much put a 3-element array list in each one of those array slots. And then every time I play a new move, I basically go to the location, the index of the element in that array that represents the number of pieces that are left on the board -1, because the array is 0 index. And then, just basically randomly draw from the size of that array, and then hold that. I usually hold that in a separate structure, and then figure out if I've lost, then I just don't do anything with the structure. It just gets cleaned up. But if I win, then I go back in and add those numbers, like add them to each one of those array lists, so that the array list kind of grows. And then just to prove that it's actually working, I actually have it output to a text file so that I can show the kids, here's how small it was to begin with, and here's how long it is now. And actually, you know what, Art, like, I have the code. I can share the code too if people are curious. If you want to take a look at it. It's not pretty, but it was just a quick and dirty thing. But just to kind of show you how that works. Does that explain the model more? I feel like I probably made it more confusing, but I'll share the code.
We got a question, next question from Susan.
Hey, Susan.
Hi. My mom's from Maui, so I have an affinity for Hawaii. For
sure. That's great. Wow.
Yeah. I guess a comment and then maybe just a connection. I loved your presentation. It's super helpful.
Thank you.
The one comment was that we have a colleague locally who's presented at CSTA meetings like maybe a year ago now, who's a professor at San Marcos, but she used to be a researcher at the Scripps Institution of Oceanography. And some of what you were talking about just connects so nicely to the work that happens at Scripps Institution of Oceanography, where they're studying in her case, they built an AI, like a camera and a robot that's down at the end of our pier that's taking snapshots and teaching itself how to recognize different forms of plankton in the ocean. And she's wonderful. Her first statement in her talk is, do you like plankton? Well, maybe you don't have any feelings about plankton. Well, do you like to breathe? Because plankton creates half of the oxygen on Earth. So if you like to breathe, you like plankton. And so you should care that we're trying to track the life and the robustness of different forms of plankton. And so they've actually trained this we have an algorithm kind of that where it's machine learning, like to recognize, just like the Chihuahua and the so that's a great connection if they ever want to. She's a woman. She's
that's neat. Okay, yeah,
using this in an applied context that's not just about security, but also about like saving the Earth, right? So, that might be super connected to your kiddos in Hawaii for sure.
Yeah, absolutely.
Yeah, with the ocean context. And then the other piece is the games that you were talking about. Just today, I was in a virtual lesson study with colleagues of ours in the math world who are have designed a discrete math class that could, for the kids who hit senior year and they don't really want to take calc because they didn't feel successful in the prior course, or they took calculus and they don't want to take the next level of calc. They've created a discrete math course that counts in our state for a fourth year math course that transitions to college. And a lot of it's about puzzles and games, and some of the exact same games that you were talking about, the mathematics community is approaching as an important foundational work in mathematics. And so I think there's just this really nice convergence between these two communities that probably don't always communicate with one another, between the CS community and this new push in mathematics to kind of think about linear algebra and discrete mathematics and all these other kinds of math that aren't calculus per se all the time. Like it's not calc all day, every day. So, so I just wanted to say that I see all these connections between, and I loved your presentation.
Thank you. Yeah, I mean, I think the reason I love computer science is because it's about solving problems, many of which just haven't really been solved before. And so it's this idea that you can, write, really. I mean, and I was an English major, so I mean, my inclination is really more as a writer, and I really hated math. But what's really interesting to me now is what I'm finding is that I learned this language years ago that I never found a reason to use until now. And then more and more, the things that I'm concerned with, which is how efficient is this algorithm? Or this is better, but how can I explain to the student why this is better? Like intellectually, I know that this is a better way to do it, but why? The way to explain it is mathematics. Mathematics is a crucial language for being able to analyze the relative efficiency of different algorithms and to be able to talk in a way that other people can understand. So it's the first time in my life, I think, where I've really understood why I spent so much time doing worksheets in high school around mathematics. And it's kind of a shame, I think, that I didn't get the context back then. But I think the more we can draw those connections between computer science and mathematics, hopefully we can get more students who are like me to understand that there really is value, that mathematics is a crucial language to understanding this stuff, but that here's why and here's how we can use it.
We have another question coming in from Mark.
Douglas, thanks for joining us today. Your presentation was really, really inspiring and wonderful. So thank you for bringing that to me. I just wanted to give you a +1 on one of your slides where you were talking about the T-shirts advertising kind of computer science in your community, and I had the exact same experience with my schools. My computer science club after school was predominantly male, and they would make shirts, and they would usually be a computer science joke or whatever, and they wouldn't get that much play out of it. But my girls in computer science, in their first year, their T-shirts said, "I've got your back. I'm a computer scientist," and their membership just shot through the roof when those got around campus.
Really interesting.
Yeah. So
yeah.
I just wanted to verify from my experience that it's exactly the same as you were describing in your slide.
Thank you for that. And it's very revealing too of people's attitudes about it. Yeah, it's really interesting. Yep.
We'll take
Great.
a last question from Hope.
Wasn't a question so much as I wonder if anybody had seen, or I know I saw it somewhere and it might have been at CSTA, just it's a short video of the kind of the dangers, the dark side of algorithms and machine learning, and how it talks mostly about Black women, and it shows all these Black women's faces and how they're being misidentified as
me. I'm raising my hand. I know where that is. It's in the CS Awesome textbook, and I can get you the link to the exact page. I think it's in unit 5, but there's only one unit that has like a social impacts or something, and it's a Black woman talking about how her face isn't recognized, and so that'll get you the pointer to that video.
Is that why Siri never knows what I'm saying?
Possibly.
Maybe.
And I'll just say that, you know, if you guys want resources about particular things, whether it's AI, machine learning, or whatever, Amy and I have this Impacts of Computing class that we teach at UCSD, which admittedly, as our students are telling us, because I made it 2.5 years ago, it's kind of getting a little long in the tooth and we need to update some things. But we could, you know, say, do you have a video on HTTPS versus HTTP? We got that. You know, do you have some things on ciphers using, you know, ciphers are sort of like precursor to public key cryptography and things like that. We've got that stuff put together, and probably the easiest way is we can just, because you don't want to hunt through our course, it's not going to be fun. Like, just let us know and we can just drop you the resources that we have.
Thank you.
Cool.
Hey,
Art, do you want to close it up?
Yeah, I had actually one last question before closing it up. You know, Douglas, I really caught the fact that you said you don't have a computer science background, correct?
Yeah.
You know, and so to me, you know, we met and talked about this a while ago, but like for me, and I think a lot of my peers right now in the space in the district I work for, we are just really challenged right now with trying to teach our computer science courses online. And I was really overwhelmed yesterday. I just felt like I just did a terrible job, you know, that because I don't think my kids are going to do well at all on these exams, you know. But what I really liked and what you brought back forth from me was the growth mindset, and something I have to think about myself because I don't have a computer science background and I'm being really challenged by it, you know. So I'm just curious to know what are you telling your kids, because a lot of them, you know, are reaching out to me and they're telling me, Mr. Lopez, I'm gonna bomb this, and I'm going, yeah, you know, it's I feel like saying it's okay, you know, we're you just try to do your best, and but you know, I feel like I didn't do a very good job of teaching some of this material because it's the first year that I'm doing it. But what is it that I really liked everything you said. I have I only have 3 girls and they're not coming to any of my meetings. I want to reach out and contact them. And so I'm just curious as to what you're doing.
Specifically with regard to the AP course, or
yeah, so AP, do you teach AP CSA by chance? I don't know.
I used to. I teach CSP now.
Okay. Yeah. But do you reach out? Go ahead.
I mean, you know, I don't have a good answer for you, Art. I wish I did. I really feel for the teachers who are kind of, I mean, I don't know what it would be like to create and explore tasks remotely. I decided a while ago that I felt that I didn't want the course to be about the performance tasks. So we actually do the create task in August with Scratch, because I found that it was actually helpful. It was better for the kids to know less to do that task, since that task is primarily about how you explain abstraction and algorithms. So we actually start, like one of the first things we teach them in Scratch is how to create a block and then attach commands to the block and name it. And right off the bat, you've got your abstraction. And we we just, by the end of August, pretty much, we're done with the create task, and then we roll right into the explore task. And so we were done with both performance tasks before the end of September, which is probably not the idea behind those tasks, but you know, my kids are done, they have them uploaded. But I think I would say keep it really simple. You know, like I basically go over the rubric with, I think, you know, I don't know how else to say it. I mean, I think the most important thing to do well on that test is to understand the rubric and understand how it's being scored. Mm-hmm. And when you understand that, I think it makes it a lot more manageable. And from a programming standpoint, what they do does not have to be that complicated. It can be done in Scratch. And they can go off and do their own independent project in a different language and do something that they're very proud of that doesn't use a list or doesn't use certain things. Because I would have things where kids would be essentially finished with a project. It was a great project, but I knew they would not do well on the performance test because they didn't add this one thing. And so they would add it in purely pro forma just to conform to the task, so now I let them do their own independent project completely on their own because I know that the task has been done and they did it using Scratch essentially, or make code. But especially since kids are not there in person, like I would suggest that no matter what language you're doing, just take them back to Scratch and have them submit a Scratch-based one. I can totally empathize. You know, the other thing that I do sometimes is manage kids' expectations about it and say, look, you're going to do the best job you can on this. And yes, like I feel very personally that I want this performance task to accurately measure knowledge, but I know it doesn't necessarily. It's not always perfect. So the score you get on an exam or the grade you get in a course doesn't represent you. You are independent of your grade. You are independent of your score. So you do the best job that you can. And, you know, and then you're going to get the AP exam score that you get, and that may or may not count for anything in college, and who knows. I try to really minimize the importance of this one score in the perspective of what the whole course is. So I don't know if that helps at all, Art. I
think it's good. It's just, I think, you know, I think what you said was really great for the AP CSP course. I'm challenged with the APCSA course, but you know what you brought back to me. Yeah, but you brought back to me.
Oh gosh, yeah, the CSP.
Yeah, that's okay. No. But I think what you said was spot on. It really helps.
Yeah,
and I'm just going to transfer the same thing over to
coding bat. I mean, I send coding bat all the time.
Yeah.
You know.
All right, and I would just to add as a parent and as someone who's like, you know, we're all like from the other side, it's just super important to remember that the kiddos they're not coming to your class for a whole host of reasons, right?
Yeah, no, yeah, I know.
They're their own social emotional well-being, and some of it is they're 6 weeks into a pandemic and they're 16 years old, right? And it's hard for us, but we have like some frames for this. For them, it just feels different. It feels punishing or depressing or just isolating. So I would wrap yourself in a lot of grace and just really take your time. The best thing you can do is make them leave this year and not feel like this class was additional stress, right? But that it was, they learned some stuff, they got exposed. When 5 years from now, when someone's talking about code, they're like, I know something about that, right? Like that's because nobody becomes an expert. I've been having this battle with my son's Spanish teacher, just to be perfectly honest. And
yeah,
like nobody leaves high school totally fluent in French. Nobody leaves high school totally fluent in CS. Like it's just not. It's a phase, and what you want them to do is not leave never wanting to learn a world language, or not leave never wanting to ever see code again. So I think you can wrap yourself in a lot of grace for that, and you've given them so much this year already, so as all the teachers have. So I think you can rest assured you've done something good already, even if they don't pass this weird wonky 45-minute who knows what exam, right? So
that's not a reflection on your teaching, you know. I mean, and I think the best thing that we can do as educators is to take care of the kids, you know, socially, emotionally. You know, I had a kid who was late on some assignments, and I requested that he meet with me. And so he met with me, and I said, hey, how are things going? And he said, it's a little stressful. My dad tested positive. And so we're trying to keep him quarantined in his own room, and it's just been really tough. And I said to him, well, you know, most people recover from it. I'm sure he'll be fine. You know, young people don't tend to get it. And after that, I felt like I just totally mismanaged. I said the wrong thing. Like, what I should have said was, wow, that must be really hard. I'm sorry that you're going through that. It must be terribly difficult for you right now. Because I should have validated what he was telling me, and what I was seeing from his not turning stuff in was that this is a very difficult thing. He doesn't want my prognosticating, which may or not be accurate. But I tend to do that. I tend to look for the solution. There's nothing, you can't fix this, right? But what we can do is empathize with where the kids are and validate where they are. And it's a really, really difficult, stressful, unprecedented place for kids to be in. And I think the more that we as educators across all the subjects can kind of support the kids and just help have them get through the rest of this semester, that's the most important job that we can do, regardless of what they get on the score, you know, score in the test or not, you know.
And I'm going to do the same thing for art right now, because the fact of the matter is, art, it's really tough. And you're teaching APCSA for the first time. It's really tough. And now you've got this extra ball of wax with the distance learning, and you don't feel connected to your kids like you normally do. Because I know you always connect with your students in a very personal way, and you don't have that for you right now. And you're doing this other course that, you know, it's stepping up. Dude, it's tough. It is not easy. But I'll tell you what, man, I had a computer science background, and my first year teaching APCSA and C++ at the AB level, I got hammered. I had so many questions coming at me. I had no idea what they were asking me. And I had a degree. So I want to invite you to forgive yourself. You are an amazing teacher, and you are doing the best that you possibly can under the circumstances in front of you.
Well, I sorry. I didn't mean to say come out across as, you know, it's just, I just think the thing is just that I think I'm vocalizing what a lot of educators are feeling right now. And I think that the main focus, I think that we start with our kids is just, hey, you know what? We're gonna get this together. We're gonna get through it, and look at social emotional learning, because that's, I think, what we focus on, and just figure it out, and just be mindful of all of that, you know. And I think that's what I want to get my message with my kids and other teachers. But yeah, it's a bit challenging, of course, and it's a pandemic. It's terrible. I wish none of this would be happening. I feel bad that the tragedies that have occurred across the world, and I have to be mindful and keep myself like that. And I think it's really great to talk to other people in your PLCs in whatever space you're in, because it's a good reminder.
Absolutely.
You know? Yeah. Well, on that note, I at 6:06, so I just wanted to stop right there for everybody. You know what, Douglas? I'm going to clap out loud. I don't know if anybody wants to join me, but you were amazing, and thank you for sharing this with us. You know.
Thank you so much. This is an awesome group. This is great. Thanks again for
I learned a lot.
Come visit.
Yeah, me too.
Thank you.
I'm
glad.
Those of you who missed it, Douglas will be joining us in Cali. He's going to be relocated to Palo Alto.
Yeah.
So if you ever made it to San Diego, and then once the whole pandemic thing finishes, you're welcome to come to San Diego anytime for our CSTA meeting.
Absolutely.
And we'll buy you 2 beers, 3 beers even.
Sounds good. Sounds good. Thank you.
Yeah.
Thank you so much.
Go for a prime.
Yeah.
Sounds good.
And I would be remiss if I wouldn't really, once again, man, thank you for coordinating everything.
Oh, yeah.
Do everything you do,
Thank you, man.
You're amazing, okay? All right, well, everybody, please stay healthy and safe, and it's really great to see you guys. I love this meeting. It makes my week.
Everybody sleep more. Work less.
Sleep more, work less. Yeah.
Yeah. All right.
Post this video next week. Douglas, can you send me your PowerPoint so I can?
Yep.
Awesome.
I'm going to use it a lot. All right. Aloha, Doug.
Thanks a lot.
Aloha.
Bye-bye.
Aloha.
Bye.
Can
Good
you,
seeing everybody. Bye-bye.
Can you stay on the line, Art?
Sure.
All right, guys, have a great week.
You too.
Have a great
Thanks,
week,
Mark.
everyone.
Thank you for your words. Bye-bye. Bye, Stephen. That drink looked awesome. I never hear her drinking.
Yeah.
My beer?
It's a pomegranate.
Your beer, I know, but
It's
he
a
had a red
pomegranate
drink.
lemon drop. My wife's been squeezing lemons for the last hour.
Wow.
Peel the first one.
She peeled them first for limoncello.
Fantastic. All right, guys, have a great week. Art, send me a note anytime you need.
Thank you, Mark. That was really helpful.
You got
Bye-bye.
it.
All right, Art. What do you want to do next week?
This is good. I think next week we could I think we do a check-in and see how everybody's doing again, you know. I don't know who else we had on Slate. Do you remember?
Tara.
Let's do Tara. Let's contact her and let's ask her, can you talk about cybersecurity and what you do with the kids? I think that's it. We're good.
Okay.
How's that sound?
Yep. Very informal.
Okay.
All right.
But man, honestly, thanks for. Hey, Brian, how are you? I just saw Brian's here.